Looking at this antiderivative, notice we see the 16x squared minus 9 under a radical. That's a hint that trig substitution may be good for us. Now here's our basic trig substitutions. Notice when it's x squared minus a squared, we want to use a secant theta. Now in this one it may be difficult to see what a is at first, but the way we would do that is we would divide out the 16, and we could rewrite that part underneath as x squared minus 9 over 16. And so a is the square root of 9 over 16, or 3/4. So we can still use our trig substitution of a secant theta with a equal to 3/4. So we're going to let x equal 3/4 secant theta, and then immediately after identifying your x, you should find your dx, because it's so common for people to forget this. And that's 3/4. Derivative of secant, not one of our most common ones, but it's pretty interesting because it has secant in it. It's just secant theta tangent theta d theta. Alright, now we're going to do our substitution. Again, the biggest mistake is people forget the dx, so let's just go ahead and start with that. On top, we're going to have a 3/4 secant theta tangent theta d theta. And don't worry about the 3/4 because there might be some canceling we can do. Now we're going to put in x, which we said is 3/4 secant theta squared times the square root of 16 times 3/4 secant theta squared minus 9. And this will work out really nice. It's a pretty slick little substitution. So now we've got 3/4 secant theta tangent theta d theta on top. I'm going to start getting rid of some of these parentheses down here on bottom. We have a 3/4 squared, a secant squared theta. And now this is cool. What's going to happen here? The 3/4 gets squared, which is 9/16. 16 times 9/16 is actually just going to leave us with 9. So under the radical, all we end up with is 9 secant squared theta minus 9. If you're not quite seeing that, square the 3/4 because you get the 9/16 and then multiply it by that 16. Now, like we've done in previous videos, this 9 can be factored out of both terms and then pulled out of the radical because it's a perfect square. And let's do a little bit of canceling at this step so we don't have to write everything again. We'll cancel one of our 3/4 with one of the ones on bottom, and this secant with the one on bottom. So let's work with what we have left. Right now we're at tangent theta d theta all over 3/4 secant theta. We factored out the 9 and pulled it out of the radical, so 3 times secant squared theta minus 1. Now the reason we do that is by the Pythagorean identity. Secant squared theta minus 1 is equal to tangent squared theta. It's going under a radical, so we have tangent theta d theta all over. I'm going to go ahead and multiply those together. 9/4 secant theta times the square root of tangent squared theta. Which is equal to tangent squared theta. Square root of tangent squared theta is just tangent theta. So this is going to cancel out with this. Now there's no other constants, so let's go ahead and pull this out. Now notice this is 1 over 9/4. So when I pull it out, I'm going to take its reciprocal, and I have 4/9. All I have left is d theta over secant theta. Well, remember, 1 over secant theta is just cosine theta. So this is actually just 4/9 times the cosine of theta. Sorry, the antiderivative of cosine of theta d theta. Okay? So it turns out that this is just 4/9 sine of theta plus c. And we are almost done. The only thing is we have to return this thing to be in terms of x. Alright, now the way that I like to do that, we'll come over here. I like to make my right triangle. Now I know that x equals 3/4 secant theta. Let's pull that down so we can see that. So we're going to use this factor right here. Alright. So we know that x equals 3/4 secant theta. Well, that tells us that secant theta equals 4x over 3. Now, I like to use a right triangle, but we could use a Pythagorean identity. There's a lot of different ways you could do this. Call one of my sides theta. Now, secant, remember, is 1 over cosine. So, this is hypotenuse over the adjacent side. So, 4x goes here, 3 goes here. So we have to find our last side, which by the Pythagorean theorem is square root of 16x squared minus 9. Now that should look familiar. Remember our original problems, 16x squared minus 9. So then, based on this, sine of theta is opposite over hypotenuse. So square root of 16x squared minus 9 all over 4x. So, subbing that into our sine theta here, we have 4/9 times square root of 16x squared minus 9 over 4x plus c. We can cancel out those 4's. And we get the square root of 16x squared minus 9 all over 9x plus c. And there's our antiderivative.